Hello and welcome back. Our topic for this video is going to be the atom. And in terms of the atom, there are going to be three components that I want you to know that are associated with the atom. All right. The first is going to be the electron. Second is going to be the proton. Third is going to be the neutron. All right. Now, in terms of biology and chemistry, the one that is going to be most important to us is going to be the electron. Now, that doesn't mean that you can ignore protons and neutrons. I may still ask you questions about protons and neutrons, but the reason you need to understand what electrons are, this is going to be the portion of the atom that's going to be involved in making chemical bonds. And those chemical bonds that are going to be important in biology are going to come up when we talk about DNA and nucleic acid. It'll come up when we talk about carbohydrates. It'll come up when we talk about proteins, okay? So the chemical bonds that are made in those molecules are because electrons are going to be interacting with one another, okay? You still need to understand the protons and neutrons also to understand kind of what's going on overall with our atom as well. So what I'm going to do is I'm going to draw an example here of an atom, and I'm going to use some different colors. Our proton I'm going to have in green. Our neutron, ooh, that's a terrible U. Our neutron is going to be in blue, all right? And I'm going to use yellow. No, wait a minute, let me use orange. That might be easier to see. For our electrons. And what we've got with those protons, neutrons, and electrons, if you notice, it's a little off-center, but the protons, neutrons are going to be in the center of the atom. And that center of the atom is referred to as a nucleus. It's not going to be the same nucleus as what we're going to talk about in Chapter 4 with cellular structure. In this case, it's referred to as a nucleus because it's contained in the center of the atom here. All right? Now, with those different components, the protons are going to have a positive charge associated with it. I remember P and positive going together. All right? Our neutrons are going to be neutral. They're not going to have a charge associated with them. Our electrons are going to be negative. All right? Now, in terms of the protons and the neutrons, they are both going to have mass. And that mass is going to be equal to 1 for each proton and each neutron. All right? Electrons, we are going to call these as not having any mass, but electrons are matter, and all matter has to have some mass. The mass of an electron is so small, it's not going to make a difference in the overall atomic number, or the atomic mass associated with an atom. So we discount it. We just say electrons don't have any mass, okay? Now, in terms of figuring out our atom here, this atom that I've drawn is helium, okay? And I'm going to do another example with carbon here in a minute. Helium is one of our inert gases. It's inert because this shell, or this circle that I drew with the electrons, you've got 2 in there. The first shell around the nucleus contains 2 electrons, okay? The subsequent shells around the outside of it, because as we go up on the periodic table, number is going to increase, number of electrons is going to increase. So the subsequent shells will hold 8, okay? And that's going to be what will allow bonding to happen. All right? First shell holds 2. All subsequent ones that we're concerned with in biology are going to hold 8. Okay? So in terms of helium then, all right, what we've got associated with helium is we've got atomic mass. This is going to be how much essentially this atom or element weighs, okay? And in terms of atomic mass, we are going to take both proton and neutron, okay? So in terms of helium, our atomic mass will be 2 plus 2, easy math. That's going to equal 4, all right? The other thing that you're going to want to know associated with the periodic table of the elements is going to be the atomic number. Okay? The atomic number is based off just, oops, there's no second R in protons. The atomic number is going to be based off the number of protons, okay? So the atomic number for helium is going to be 2, all right? Helium can't make any bonds because the electrons in that first shell are complete, okay? So in terms of that, I want you to know the difference between the atomic mass and atomic number, okay? And in terms of that, you will see some differences as far as between the atomic mass and atomic number. The example I have in your notes is going to be for lithium. With lithium, the atomic mass number is going to be 7. But it's number 3 on the periodic table. That tells you there are 3 protons in lithium. That means those other 4 that make up the 7 in the atomic mass have to be neutrons. Okay? So in terms of that, these are kind of even numbers. They aren't always going to be even numbers like that. Don't let that throw you off. Okay? Because the one I'm going to do next with carbon, because carbon is going to be a very important molecule or element that we are going to discuss in class. Also, like helium, kind of balance, it's even numbers, okay? It isn't always going to be even numbers, all right? 3, 4, 5, 6. All right, so with carbon then, we're going to have 6 neutrons, 2, 3, 4, 5, 6, and we are going to have 6 protons, all right? With our electrons, like helium, we'll have 2 in that first shell, okay? And then in our next shell, we're going to have 4. So let me draw these a little bigger, even though electrons should be small. Okay, these are our electrons. And I'm going to just indicate with a circle here, this is going to be empty. All right, so the empty blue circles that I have here, that represents 4 potential bonds that carbon could make with other elements. All right, that's why carbon's going to be important as far as one of the elements that we're going to cover this semester. All right, now in terms of looking at atomic mass, okay, our mass of our carbon atom is going to be the number of protons and neutrons. Okay? The atomic number is going to be the number of protons. Okay? Now, typically when we're talking about figuring out how many electrons each element has, for what we need in biology, typically the number of protons held within the atom is going to equal the number of electrons, okay? So in terms of carbon here, our protons, we've got 6. Our neutrons, we have 6. And our electrons are going to be 6. All right? So in terms of determining the atomic mass, you're going to take protons plus neutrons. I'm going to let you do the math on that one. Okay? That's going to give you the atomic mass. Atomic number is going to be equal to the number of protons in carbon. Okay? Now, in terms of the atom, this is our basic atom. The next video I've got is going to talk about a special type of atom, which is called an isotope. And we'll talk about what some of the differences are between an isotope and an element. Okay? Thank you for your attention. If you have any questions, please let me know.